to an element of B. Okay, so we have that. So we know that the first condition holds. Everything over here has an arrow going over here. But 2, okay, clearly we have 2 is mapped to 4, okay, and we have 2 is mapped to 7. Okay, so we have a situation where we have 2, the same element in A is mapped to different elements in B. Okay, so clearly we have this situation here where 4 is not equal to 7. So hence we have that G is not a function, if that makes sense. Okay, so G is not a function. Okay, let's do another example. Okay, Okay, let's say we have something like this. Okay, so let me just fix these pages here. Okay, so let's say we have let A equal the set 1, 2, and 3, and B equal the set 2, 3, 4, and 7, and let H be a relation from A into B. Okay, and it's defined by, okay, so A is a relation from A into B. What I mean by that is, sorry, H is a relation from A into B. So H is a mapping from A into B. Okay, defined by the following thing. Okay, where H is equal to the set of ordered pairs. We have 1 is taken to 3. We have 3 is taken to 4. And let's just leave it like that. So what does the mapping look like? Okay, so we have our set A, we have our set B. A contains the values 1, 2, and 3. B contains the values 2, 3, 4, and 7. And the mapping is defined to be 1 is taken to 3, so 1 is taken to 3, and 3 is taken to 4. So there we go, 3 is taken to 4. Okay. Now what about our conditions of a function? So we're defining this particular relation to be a mapping from A into B. So if it was a function, well then every element of A must be mapped into B. Okay, and here we have clearly, okay, 2, which is an element of A, okay, is not mapped into B, if that makes sense. So we don't satisfy the first condition, so it's not a function. Okay. We do satisfy the second condition. Okay, there are no ordered pairs. Okay, there's no ordered pairs A, B, and A prime, B prime. Okay, where A is equal to A prime and B is not equal to B prime. There's none of them in there, so it actually satisfies the second condition. There's no double arrows coming out, if that makes sense. There's no double arrows coming out from single values into separate values over here, so we do satisfy the second condition, but we don't satisfy the first condition. So H is not a function. Okay, H is not a function. Okay, and maybe what we'll do is we'll define one more example. Okay, so let's define one more example. Okay, let me just take this here. Okay, so what we've defined so far is we defined in a situation where we have both conditions are satisfied. We've defined a situation where the first condition is not satisfied, but the second condition is satisfied. And let's then find a situation where, so let's find a situation where both conditions are not satisfied. So we have let A equal 1, 2, 3, and B equal, let's say, 2, 3, 4, and 7, and let I, okay, be a relation, okay, from A into B. Okay, so I is a relation from A into B, which means it's a subset of the cross product of A cross B. Okay, so it's a subset of A cross B. Okay, if that makes sense. Let's say it's a relation from A into B. So that means then that I takes values from A into B. Okay, and let's define it by defined by the mapping I is equal to the set of ordered pairs. Okay, 1 is taken to 3, we have 3 is taken to 7, and we also have 3 is taken to 3 is taken to 2. So there we go. There's our mapping. That's a subset of the cross product A cross B. So it's a relation. Okay. But let's have a look at it from a, let's say, from a graph perspective. We have A, we have B. A are the values 1, 2, and 3. B are the values 2, 3, 4, and 7. The definition of the function says 1 is mapped to 3. So here we go. 1 is mapped to 3. 3 is mapped to 7. There you go. 3 is mapped to 7. And we also have 3 is mapped to 2. So 3 is mapped to 2. What about our conditions? Well, condition 1, okay, clearly 2 is an element of A, but 2 is not mapped to B, into the set B. So we don't satisfy the first condition. 2 doesn't go across here, okay? So really what we're saying here is that for I, that the domain of I is not equal to A, okay? That the domain of I, that's the values that I take from here across, okay, don't include all the values in A, so we don't satisfy the first condition. What about the second condition of a function? The second condition, well, clearly we have that 3 is mapped to 2 and 3 is mapped to 7, okay? So we have 3 is mapped to 2 and we have 3 is mapped to 7. That's the double arrow coming out, okay? But the 2 here is not equal to the 7, okay? So hence it's not a function. So it doesn't meet both conditions. So I is not a function, if that makes sense, okay? So that's an important characteristic here. In the next video, what we're going to do is we're going to define functions where we use some of the familiar sets, like we use the natural numbers, we use the integers, we use the rational numbers, we use the irrational numbers, and we use the real numbers, and I suppose we could also use the complex numbers, okay? Where these sets here, okay, become our domain values, okay, and our codomain values, okay. That's going to be important, okay, for us. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland, and I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for us. Okay, thanks for watching. Okay, bye bye.